Geometric construction lines, angles, and shapes that are drawn accurately using only the simplest drawing tools. To create geometric constructions, you will need paper, pencil, a straight edge so you can draw a straight line, and a drawing compass to swing arcs and scribe circles. Make sure your drawing compass has a sharp needle on one arm and a sharpened pencil on the other arm. The straight edge and pencil are your tools for drawing straight lines, line segments, rays, and sides of polygons. Adding the drawing compass allows you to copy any of those constructions accurately and faithfully. To draw a straight line, hold the straight edge down on your paper, put the tip against the straight edge and the pencil nearly vertical. This keeps the point tight against the straight edge as you run the pencil along the straight edge. Once the line is drawn, label endpoints for line segments, identifying points for lines, or an endpoint and an identifying point for rays. Remember to use arrowheads for lines and rays. Copying a line segment requires the drawing compass, pencil, and straight edge. Next to the existing line segment, draw a new point. Call it point L. Place your drawing compass needle on point G. Open it to reach point O and carefully lift it up. Relocate the needle to point L. Swing an arc out to the right using the exact setting that was the distance of the original line segment, GO. Use your straight edge to draw a line segment from point L to any spot on the arc. Your new line segment is identical in length to your original. Label its endpoint point D, and you are good as gold. Now let's look at how to copy an angle. Here we have two rays sharing the common point I. Rays SI and LI form an angle, angle SIL, or angle I. Draw a new point, which will be our new vertex, off to the right. We will label it point E. Use the straight edge to draw a line from point E off to the right with an identifying point along it. Label it point R, and put an arrowhead on the right end. The next steps are tricky. You will be using only the drawing compass to measure and copy distances from the original angle to the new one. Open your drawing compass up so you reach from point I along the two rays very nearly to their neat little arrowheads. Swing the compass to run a single arc across the original rays SI and LI. Without disturbing the compass setting, relocate it to point E on your new ray. Swing the compass up so visually you are fairly certain to have drawn an arc at least the size of the first arc. Go back to the first angle, angle I, and put the needle on one of the intersections of a ray and the arc. Open or close the compass so the other arm reaches the other intersection of the arc and the other ray. Without adjusting the compass, relocate the needle to your new construction and swing an arc that intersects with the arc you previously drew from the vertex point E. Where it crosses the other arc, you have found a point that will be along the new ray from point E upwards and to the right. Connect point E to that new point and call it point V. Put an arrowhead on the ray. You now have an angle identical to angle SIL, called angle VER. You can also use a compass to bisect an angle or a line segment. For a line segment, open the compass to a bit more than half the line segment's length. You can do this visually. It does not have to be measured. Place the needle on one endpoint and swing an arc above and below the line segment. Relocate the compass to the other end of the line segment and repeat the swing. The points where the two arcs intersect above and below the line segment are the 2 points to connect with your straight edge. That straight perpendicular line will bisect the line segment. To bisect an angle, hold the needle of the compass on the vertex. Open the compass to stretch most of the way along one ray. Swing an arc that crosses both rays. Without adjusting the compass, relocate the needle arm to the intersection of the arc and one ray. Swing an arc in the angle's interior area. Without adjusting the compass, relocate the compass to the other ray where the first arc intersected. Swing an arc. Where the two arcs intersect, that point is an endpoint of a line segment that bisects the angle. Connect it with the straight edge to the vertex point.